The College of Arts and Sciences at Stony Brook University presents The Difference You Make, where we hear weekly from people who make a difference in our world. Here now, the Dean of the College of Arts and Sciences and Professor of History, our host, David Robel.
Hello, my name is David Robel, Dean and Professor of History in the College of Arts and Sciences at Stony Brook University. On today's episode of The Difference You Make, The Ideas That Matter, I'm joined by Greg Henkes, an Associate Professor in the Department of Geosciences. A little bit about Greg before we get started. Greg's also affiliated with the School of Marine and Atmospheric Sciences, the Interdepartmental Program in Anthropological Sciences, and the Turkana Basin Institute, TBI, which we'll be talking about more during the course of the program. His research interests include the stable isotope geochemistry of light elements and their use as recorders of the climatological, biogeochemical, and ecological evolution on Earth. And I'll start there. You very kindly said to me right before we began that geochemistry is much like history. So as a historian, help me get started on the work that you do.
Sure. Well, thank you for having me. It's a pleasure to be here. And I think what I meant by that when I said that before, what we're trying to do in geology and using sort of proxy evidence through the geochemistry of materials is really to tell a story about Earth's history. And so that's, I think, what I was alluding to.
So you're trying to determine change over time.
Sure. Yeah, exactly. Yeah. So the whole idea is sort of premised on these little recorders that are either in the ocean, maybe in a lake, maybe in soils, and those things, and their chemistry is just sort of passively recording the ancient environmental conditions. And part of our job is to kind of go out into the field and collect materials, bring them back, and understand their chemistry in a way that we can kind of reconstruct that history.
But a deep history of time.
That's right. So that's maybe where our...
So historians often get hung up on this theme of prehistory.
Right.
One of my colleagues in the field wrote to me recently and said, prehistory is a terrible, terrible concept that we need to move beyond.
Right.
If we can just understand, we need to study change over time, and sometimes it will start at the time of ancient civilization, sometimes it won't, but that should not be our simple gauge. So,
well, I think we kind of have an analogy in geology. We use this term Precambrian, which refers to the sort of first several billion years of Earth's history,
right,
which is often kind of invisible in the rock record. The sort of nature of the geologic record is the younger the rocks are, the more abundant they are at Earth's surface. And so our Precambrian is your prehistory. Yeah. And I think there is, I'll get lots of eye rolls from my colleagues by saying that, because the Precambrian is fascinating for all sorts of reasons. So it's often hard to sort of group things into those kind of catch-all terms.
So part of the conversation I'm having with that historian colleague is whether history can be or should be science, and the degree to which history is a discipline governed by interpretation, the degree to which science, at least on the physical side, is a discipline wherein phenomena can be measured and remeasured. So in your line of work, there is some uncertainty, isn't there?
We are dealing with uncertainty all the time. I had a meeting with a student this morning, and most of the hour we just talked about uncertainty. Uncertainty in where we are in time, uncertainty in the kind of measurements and the data we create in the laboratory. And I guess to respond to your comment, is history science? I think it is. And I think the thing that might distinguish descriptive history from something like geologic science is all how it sort of handles questions, right? Mm-hmm. How do we use a question to motivate us to do, make observations and think scientifically in the rock record is not all that different from probably asking questions in a historical context.
Yeah. Thank you. So going just a little bit deeper, your lab here is focused on making novel stable isotope measurements from samples collected across a wide range of temporal and spatial scales, and that research focuses on temperature and isotopic evolution of seawater. That's one thing. Let's start there.
Sure. I guess on that thread specifically, it was sort of the theme that emerged from my graduate work was really trying to understand the sort of temperature history of Earth. And I spent most of the sort of early part of my career as a graduate student and as a postdoc prior to coming to Stony Brook, thinking about that in kind of a global ocean context. And then when I got here to Stony Brook, importing some of those tools that I had been using in the laboratory, and thinking about that in the context of temperature change on the continents in sort of terrestrial ecosystems.
Yeah. And then also the evolution of carbon and nitrogen geochemistry in the ocean. Tell me more about this.
Sure. So we use stable isotopes of elements, mostly light elements. And if we were doing this interview in my lab, it'd be noisy, and part of that noise would be all of these instruments and vacuum pumps that are sort of churning away in the background, allowing us to take geologic samples, things that contain carbon and nitrogen, and sort of convert those into a gas, and then port those into these instruments that separate on the basis of the stable isotopes of those elements. And then we use those stable isotopes as sort of passive tracers of ancient or contemporary environmental processes. So that carbon and nitrogen biogeochemistry, this sort of global carbon cycle. So you can think about that in the ocean in terms of, little phytoplankton growing in the surface ocean. You can think about that in the atmosphere, the CO2 that's in this room or outside the building right now. All of that is sort of connected on a kind of mass balance way if you zoom out on a sort of planetary scale. And these tracers that we measure in my lab, those sort of respond to changes in that global equilibrium for the carbon and nitrogen cycle.
Okay.
And so we're using those in sort of very specific ways, but ultimately the science is connected to my colleagues elsewhere, sort of asking and answering questions that have to do with a kind of long-term and global scale evolution of carbon and nitrogen on Earth.
Okay, that's great. Thank you. Let's focus in on a particular place. Let's move to Kenya and the Turkana Basin Institute and the work that you've been doing there over a significant period. So the climate and environment of East Africa.
I was just talking about the ocean. I can hardly think of a kind of bigger system on Earth to try and wrap your arms and head around. And then you can take that sort of same concept and same sort of geochemical lens and apply it to a much more refined sort of specific geographic area. And so one big thrust of my research and since I got here in 2016 has been to work on the same sort of questions, but isolated to this really important basin in Eastern Africa where we know from the geologic record sediments and volcanic rocks that are found there. Those rocks contain a paleontological, a fossil record of the last 20 million years or so of evolution in Eastern Africa. And then the most exciting part, why everyone really gets excited about Turkana, is in the last 4 or 5 million years, that's one of the best records we have of human history and human evolution.
Yeah. Tell us a little bit more about the scale of this Stony Brook operation at TBI. This is a big part of the identity of the university, I think of the college, and a really good example of how a range of different departments can work together, sort of not just at the seams of their disciplines, but even seamlessly.
Yeah. When you first said scale, I was trying to think of I thought you meant how big of an operation the whole Turkana Basin Institute endeavor is, and I can talk about that. But
I think it's both that and the scale
disciplinarily, geologically. Yeah, I think it's one of the more special things about working out there is I can go out there as a geologist, but I can bore students and my colleagues pretty quickly just talking about the geology. And that's in part because they know the fossil record is really interesting. But I can also, it's more enriching to go out there with paleontologists, to go out there with paleoanthropologists, to rub shoulders with ecologists, and I think all together sort of come up with a better understanding of what was happening at the, I could tell you how much grass was on the landscape 8 million years ago, but that's only interesting if you're also talking to a paleontologist who's telling you the taxa of bovids that were running around, or 4 million years ago, what kind of hominids were on the landscape. And so I think that's kind of the most compelling, whether you're a student who's on a field program out there or you're trying to pitch your research to the NSF, that you really can't just tell one story of the geology without also talking about the sort of evolutionary history of the life in the basin.
Now, in terms of students engaged in the work there, this is the Turkana Basin Institute is a study abroad option in the fall or the spring, in the summer as well. Tell me more about the work that students do there.
You're going to get a real sense for my enthusiasm. Yeah. I mean, to say it's world-class is not just, we can say world-class and use a term kind of colloquially for various things. It truly is a sort of world-class opportunity for students to learn in. It kind of takes this idea of experiential learning, of kind of learning something in the classroom, and then in some ways you can just literally go out the back door at some of these Turkana Basin Institute research stations and see the exact same rock that you just saw a picture of in a PowerPoint slide. Yeah. So I think this is just immense resource for Stony Brook students, but I think really puts Stony Brook and the departments in the College of Arts and Sciences who send students out to Turkana, puts a asterisk up by Stony Brook's name, I think, in terms of the accessibility and access to this really unique place.
I'd like to suggest at the risk of controversy that this is not so much about the planning of a flag of a university or of a nation in a place. This is an institute that brings together scientists from across the globe. Can you talk about why that is so important right now?
Well, I think sort of global politics, people coming together, especially kind of immersing yourself in the rich culture in Kenya. Often when I'm in Kenya on the way to Turkana is this sort of mythical place, even in the eyes of lots of Kenyans. Most of the population in Kenya lives somewhere in or around Nairobi. Yeah. And there's essentially only one commercial airline that services the entire Turkana County, which by area is one of the largest counties in Kenya. TBI has this incredible sort of access to a bush plane, which also provides researchers with a kind of shuttle to get to and from Nairobi.
So you get to Nairobi and then you take a bush plane to TBI.
Yeah. It's sort of like, I don't know, pinch me kind of like, occasionally I get to fly in the co-pilot seat. And the last time I was there with students, I had the students fill out, a like bingo for all of the incredible sort of geography and geology that they were seeing as the sort of landscape of the East African Rift kind of unfolded beneath us. So
amazing.
World class. Yeah, really. Yeah.
Your mentorship of students here and there, can you talk a little bit about why that matters, why ensuring that new generations of emerging scholars are brought into association with this research site?
Yeah, I mean, maybe at first it's helpful to kind of go over the different kinds of students that have the opportunity to go to Turkana.
Because you've got there are undergraduates as well as doctoral students there.
Exactly. So it's really that kind of full spectrum of students. It's not cheap to get to Kenya, but I also point out, it's not cheap to fly to Wyoming, and it's maybe just as expensive to kind of operate on the ground somewhere out west. And I think what you get for the 14-hour plane ride that you have to take to Nairobi and all the travel is really kind of a access to the sort of best classroom that I could imagine.
Yeah.
It's a desert, kind of harsh desert scrubland ecology, and it's challenging for students, but I think a lot of them sort of take on that challenge, and it's part of the experience is the challenge, and I think that, sharpens the mind and creates different kinds of learning environments.
The experience transforms their lives, surely.
I think so, yeah. I think everyone who has a sort of fortune to travel to Kenya and to Turkana has their lives changed. Yeah.
So we're approaching an important anniversary of the university's work at Turkana. Can you say a little about that? I think you have some events coming up to mark that anniversary.
That's right, thanks. Yeah, so in 2005 was when Richard Leakey, together with Shirley Kenny, then president of Stony Brook, kind of came up with the idea of the Turkana Basin Institute, and I think it's today sort of living through that sort of foundational vision of Richard together with Shirley. And in the interim, I've only known it for the last decade or so, but has grown from kind of that seedling of an idea to 2 large field campuses, an office in Nairobi in the capital, and then a kind of persistent presence here on campus as well.
That was a big risk to take for the university.
I think so, but if I don't know if you had a chance to meet Richard
yes.
I mean, it's just he was that kind of person, that made it feel like it wasn't such a risk. Right. So this fall, we're on October 22nd, we're going to sort of celebrate the 20 years. So 2005 was when those first conversations started happening, with a one-day conference held here in the Wong Center. That's both meant to sort of celebrate the last 20 years and also seed sort of new ideas about how faculty, students, researchers can all engage and get better access to.
I'm guessing that this symposium will also provide an overview of the remarkable work that's already been done.
Absolutely. Yeah. Yep. Yeah. So it's just going to be a one-day event, but it's actually hard to kind of put 20 years in one day. But we'll feature folks who have been working in Turkana, leading research programs there, faculty in anthropology, geosciences, ecology, and evolution. We'll hear from the sort of emergent Simons STEM Scholar program, which conducted a sort of inaugural field program last winter.
And you've been mentoring a Simon Scholar student this summer.
Yeah, so I really just kind of stumbled into that. We have one Simon STEM Scholar who's a geoscience major, and it just sort of met in the hall, essentially.
Say a word or two about that program. It's an incredibly innovative program that provides these high-impact research opportunities to undergraduate students.
I know I met the cohort of them out there. I wasn't able to go for scheduling reasons for the whole trip, but I met them in Turkana pretty much immediately. You sort of got a sense for what a special group of students this is. And I think their perspective on their own education and their ambition has just been sort of turbocharged by the program, by the Simon STEM Scholars program. So I felt really, fortunate to be involved.
Yeah.
And they're all over. Like I see them walking across campus still.
They're an amazing group of students.
Yeah.
Yeah. Thanks in advance for your patience with me as I veer off into a couple of areas that, as a historian, I just would like to understand a little bit more. As a historian who's a dean, I'm often asked to provide support for different kinds of instrumentation, and mass spectrometry is a big part of that landscape. Talk to us about why this matters so much.
Okay, so I'll do a little promo, which is, I spend quite a bit of time in Kenya, and my family and my students and everyone in geoscience, they know me more as the like lab rat, a guy
Yeah.
who kind of hangs out in the lab, rolls up my sleeves. I'm going to head back to the lab after I'm done here and work with a student. So these instruments are, highly specialized. They cost a lot of money to acquire, but also to run. And really the trade-off that you get for all that money and all the sort of blood, sweat, and tears that you put into the lab is a chance for students to run their own samples, to kind of get dirty, to break the instrument and figure out how to put it back together. And these are instruments that they require constant attention, but all that effort is so that you can sort of make these incredibly precise, incredibly difficult measurements and put little pins on, a geologic timescale that says, soil temperature was 30 degrees Celsius in the Turkana Basin in the late Miocene, and there was, a certain amount of grass on the landscape, and the hydrology was this. Is sort of like sorcery in a way.
It's incredible. How is the machine doing that?
How long do we have?
3 minutes.
It is taking, we basically destroy rocks. This is how I put it to groups who come through. And we're sort of like, lots of my colleagues really like rocks and they want to keep the rocks in pristine condition.
Yeah.
Our lab just takes the rocks and destroys them in systematic ways and creates essentially a gas from the rock. Right. That gas could be nitrogen, dinitrogen, and it could be CO2, it could be O2. And then we take that gas and put it in the source of a mass spectrometer, which ionizes the gas and sort of creates an ion beam.
Got it.
And then the ion beam passes through a magnetic field, and that magnetic field and the way that the collectors are positioned at the other end of this instrument, that magnetic field sort of separates out the gas in terms of the mass of the elements in that gas. And so it's like a prism, Yeah. And so the heavy isotopes kind of go further into the magnetic field than the gases with the light isotopes, and they come out sort of separated on the other side. And then we've got little detectors that are sitting there counting different gases as they come out and transferring those into ratios of isotopes.
Yeah. So. Yeah. Thanks. I think our listeners will really benefit from that breaking down of how this instrument works. I want to finish up with a last question for you, sort of taking you back. I knew at a really young age that I wanted to be a historian. I didn't know what a historian was, but I knew I wanted to be one. My mother used to take me to these historic sites, and I would buy these little pamphlets that described the history of these sites, and I thought that's what a historian did. Yeah, I thought this is the coolest thing. I get to write these little pamphlets that I buy at these historic sites, and it turned out that's not really what historians do. But how did you know? When did you know that you wanted to study geology? What was it that prompted you to explore this field in the beginning? How did those ideas start?
Again, how long do you have? I'll do it really quick. So maybe I shouldn't be telling my boss this, but my degree actually as an undergraduate is in biology. It's not in geology. And the reason that is I sort of thought I wanted to be a marine scientist. I grew up in Maine on the coast, fishing, swimming in the summers on the coast of Maine. How could you not want to be a marine scientist?
Or a historian.
Or a historian, sure. Yeah. I went to college and wanted to do marine science, and it wasn't until I was maybe a junior where I realized actually the thing that I was interested in, you use the word sort of biogeochemistry, it was more like that and less like, studying fish or something, Right. But I really I went and did a NSF research experience for undergraduates in like fisheries biology. Yeah. I really kind of explored all of these areas of marine science and just sort of stumbled into biogeochemistry through a really impactful professor. And so I realized I'm in the wrong major, but it was too late. So I convinced my biology major advisor to accept a lot of geology elective credits.
Okay.
And so by the time I got out, I was like kind of had one foot in biology and another one with a bunch of geology courses.
So by the time you were applying to graduate school, you had a flexible enough record.
That's right. Yeah. That's right. Yeah. So, and then I had a research experience actually in the Arctic as an undergraduate. I was really fortunate. I got to go, my advisor, my thesis advisor sent me to the Svalbard archipelago in Norway, and they put me on an icebreaker. In hindsight, you're like, what? Yeah. I was like a 19-year-old kid. I don't know.
What an incredible experience.
It was incredible.
To have, yeah.
Okay. So, but I knew no Norwegian. I just got introduced to these Norwegian colleagues out on the ship for 2 weeks. And there was a big mast on the ship. And I asked the captain, that it was very kind of casual on the ship. I asked him, can I climb up the mast? And I could see there was a little observatory on the top of the mast. And so I got to climb up there, and the sort of ice, the sort of sea ice was unfolding beneath the ship, and the ship was kind of slowly kind of crackling over the ice. And I just thought to myself, I was like, I just want to do this, for the rest of my life. Like, how do I do that? And the answer ended up being this sort of discipline. It turns out I'm kind of good in the lab doing this stable isotope thing, and I can kind of evangelize on these specific area of geochemistry. But it was that moment as an undergraduate where I was just like, man, I just want to keep doing this. It's sort of selfish, and the side effect of all of this is getting to teach students and try and create similar kind of scenarios and situations for students to really get inspired.
So the big Turkana Basin Symposium Conference is on Wednesday, October 22nd, and you're presenting. Tell us about your presentation at the conference.
Sure. My presentation will be kind of in a block of other faculty who have kind of formal affiliations with the Turkana Basin Institute. Other faculty are from other geoscience faculty in anthropology and ecology and evolution. I'm going to talk more about my research in a particular period of Earth's history called the Miocene. Before that block of speakers, we're going to hear from some early leaders of the Turkana Basin Institute, and after that we'll hear from some kind of forward-looking thoughts and perspectives from faculty, both within the College of Arts and Sciences, from School of Marine and Atmospheric Sciences, and elsewhere across the university.
Is there a place for faculty outside of those core science disciplines? Is there a place for our social and behavioral scientists or our humanists or artists to have an impact?
Absolutely. I think the idea of this conference is to sort of inspire participation as sort of widely across the university as possible. We want folks from history, we want artists, we want even those in the sort of health sciences and across the street at the hospital to, through this conference, sort of envision ways that they could interact with either Turkana Basin Institute on campus and then hopefully get them out into the field in Turkana in Kenya.
That sounds great. Thank you. Well, from the cold of the Arctic to the heat of the Turkana Basin, Greg, Professor Henkes, thanks so much for the difference that you're making in the lives of our students, in the field of study, and in ensuring that the Turkana Basin Institute is an example of the kind of global science that makes the world a better place.
Thank you so much, David. It was a pleasure.